recording that to put marbles in bag. So we are having k bags, okay, on and we are following zero index integer, okay, and weight I is the weight of the ith marble, okay. So we have been given the some number of marbles, okay, and k number of bags, okay. Now weight I denotes the weight of the ith marble. So and what is the task we have to perform is that we have to divide the marbles into k bags according to the following rules, such that no bag is empty. We have to divide the marbles such that no bag is empty, means each bag have at least one marble. If the ith marble and the jth marble in a bag, then all the marbles with an index between the ith and the jth index should also be in that bag. Suppose you are taking all the marbles, taking the marble number I and j, okay. Then what will happen is that you will have to take all the marbles in between the I and j. Okay. You will also have to take the all the marbles in between the index I and j. That's what it is talking. If the ith marble and the jth marble are in a bag, then all the marbles with their index between the ith and jth index should also be in that bag, same bag, in the same bag. Okay. Now, if a bag consists of all the marbles with an index from I to j inclusively, then the cost of the bag is weights I. So suppose you have put it in a bag, means between marbles between the I and j. So what will be the cost of the marble? Wi and wj. Basically means the two marbles at the end. Sum of the weights of the two marbles at the end will be the cost of the bag. Okay. Now uh, you have to now it have been defined that the score after distributing marble is the sum of the cost of all the k bags. Okay. So what would be the score of the distributing the marbles? So suppose you have decided the distribution, and now you have to compute the score of the distribution. Okay. So how can you compute the score of the distribution? Is the sum of the cost of all the k bags. This is the cost which you have defined in of the cost of a bag which you have defined in this way. You have to sum up for all the k bags. Okay. Suppose this is the other bag, this is the other bag, and so on. Okay, and so on up till k bags. So you have to sum up the cost of the all the k bags, and that will be the score of the distributing the marbles. Now what you have to find is that return the difference between the maximum and the minimum scores among marble distribution. Okay, so you have to first compute the maximum scores you can get in a distribution, in a particular distribution, and now and the other one and the other thing is the minimum scores you can get in a distribution. So let's consider this example, then you will be clear with the question. Okay, so what does this you have 1351. So if I partition this like this, okay, so I have got two the marbles for the two bags, because k is equals to 2, so we have to distribute among two bags. So what will be the cost? 1 plus 1. See here, 1 plus 1 cost of the first bag, and what will be the cost of the second bag? Since we have included the marbles from 3 to 1, so it would be 3 plus 1 is equals to 3 plus 1 is equals to 4. So 1 plus 1 is equals to 2 and 3 plus 1 is equals to 4. So cost would be 6. Okay. And now another distribution can be that I have distributed like this. I have distributed like this. I have distributed from here. So what would be the cost of the first bag? 1 plus 3 is equals to 4. Okay. And what would be the cost of the second bag? 1 plus 5 is equals to 6. So what would be the over score score of the distribution? It would be 10. So Here it will be the maximum score and the minimum score would be 6, which we have computed earlier. So we have to return 10 minus 6 is equals to 4. Means we have to return the maximum score, difference between the maximum score minus minimum score. So how to think of the solution? How to think of the solution? Suppose suppose you have the weights A, B, C, D, E, and F, and suppose K is equals to 3. Means we have to distribute among 3 bags. Now one thing you should observe, whatever the distribution, whatever is the distribution, what will the A and F would always be in the cost. Means what I mean is that suppose you have distributed like this from here and here. Okay. So what would be the score here? A plus B, because it will be the cost of the first bag. Then C plus D. C plus D would be the cost of the second bag. And E plus F would be the cost of the third bag. One thing you have observed, whatever will be the distribution, A and F will always be there. So what are we left with? What are we left with? We just have to suppose if k number of partitions we are if k number of bags we are having, then what is the number of the partition you are required? Obviously it would be k minus 1. You can see here I have just done 2 partitions and I am getting filled with 3 bags. It's clear. So what are we left with? You can see here that the cost of the first partition means the wherever the I am doing the first partition, all the partition would be like this. Suppose you have done partition here, then what would be the weight which will contribute to our answer? It is B plus C. Okay, and the second partition you can see D plus E. Now if you have carefully observed that we can make our answer. How can we make our answer that A plus F will always be there, and the only thing we are left with is have to decide K minus 1 partitions. K minus 1 partitions. And how to decide the K minus 1 partition? That we have to take two adjacent element. We have to take two adjacent element for making a partition. Okay. So uh, will it not work that if uh, I obviously know that A and A plus F will always be there. Now, what if I just push the if I use a priority queue, since I have suppose for the minimum score, what you will be required for the minimum cost, what you will be required? You will have to decide the partition at the position where this sum this sum B plus C plus D plus E is minimum. Don't you agree with me? And for the maximum one, you have to do the partition in such a way that B plus C plus D plus E is maximum. Okay. And one thing, the maximum and the minimum will always have A plus F. So these are don't care. Although if you push this in the priority queue, it will be obvious, but it will not affect our answer. So we can ignore this. Since I have told you how to make the partition, suppose if I make the partition here, then the cost which will be contributing to our score would be A plus B. If I make my partition from here, then the C plus D would be contributing to my score. If I make my partition here, then what would be the E plus F? E plus F. Okay. So now for the minimum one, I would take a min priority queue, min heap. Okay. and for the maximum one I would take a maxi, and what I will push just the sum of the two adjacent elements in both of the queues. Okay, for now you I am sure that you would have get the approach that suppose now if I have pushed the maxi, what will it return? We will have to just uh, pop out k minus 1 elements from the max heap and k minus 1 elements from the min heap. Okay, and we have to sum up all these individually, means I means individually for the k minus 1 elements of the max heap and k minus 1 elements of the top k minus 1 elements, top k minus 1 elements of the min heap, and just take the difference, you will get the answer. Because if I am using the max heap, I will get the k minus 1 maximum partitions where I will get the maximum answer. Okay, and if I using the min heap, then I will get the k minus, I am doing the k minus 1 partitions where I can get the minimum answer. So let's move on to the core part. Okay, so I am creating a max heap and min heap. So it is the min heap. Similarly, now I have created a max heap. Now what I will do is that first I will get the size of the weight array. Okay, as I have told you earlier that the last two elements will be always be there in our score, so I will not consider this. Means uh, I will told you, although you can, if you consider the answer would be remain the same. Okay, for int I is equal to 1, I less than I plus plus mini dot push weights of I plus weights of I minus 1. Okay, means I am pushing the two consecutive, because the two consecutive elements, the partition will be there only between the two consecutive elements. Maxi dot push weights of I plus weights of I minus 1. Okay, now what are you required with only? You have to just, since A and F means the two ends element will not contribute to our answer. Why? Because this will always get cancelled, because it will always be present in the maximum and always be present in the minimum. So when we take the difference, obviously they would get cancelled. So we only have to take k minus 1 partition. So k minus minus first I will do, and now until k minus minus, so until the k is greater than 0, I have to just pop. I will first take an answer variable long answer is equals to 0. Okay, and I will just push answer. I will just take the difference of the uh, top elements of the max heap and the top element of the min heap. Although you can do separately, what I mean is that you will first pop the k minus 1 elements of the max heap and take their sum, and then take the k minus 1 elements of the min heap and take their sum, and then return the difference between them. But I am doing them concurrently. So maxi dot top minus mini dot top, because at last we have to do the same thing, so why not do it parallelly. Maxi dot pop and mini dot pop. So now return answer. So yeah, it's that. Let's submit it. So it get accepted. So what is the time and space complexity? The time complexity would be, first you are inserting the adjacent, so n minus 1 you are inserting, so it would be n log n for the min hip and the max hip. It would be 2n log n because you are separately doing this. And suppose n is the number of nodes in the max hip and the min hip, so it would be the space complexity would be big O of n. So yeah, you can say it would be n log n time complexity, n log n time complexity, and big O of n space complexity. Thank you.